Okay, so we also have to be able to dilate lines. And I know that seems really weird considering a line goes forever in both directions. So how do you dilate something that's already infinite? But it's not really so much that you're dilating the line itself. It's just the location of the line basically changes depending on where the center is. That's basically what's happening. It's important to remember, and we talked about this in the last lesson, that dilations preserve parallelism. So when you're dilating the line, the pre-image and the image are parallel. That's an important piece. Otherwise, we really wouldn't be able to do the rest of this. So when we're centered at the origin, that's super, super, super easy. So if I take this line, I'm just going to plot it really quick. If I have 2x plus 3, that has a y-intercept of 3 and a slope of 2. So let me just plot this really quick so that I can show you. Okay, so here's my line. Looks kind of like that. There's y equals 2x plus 3. Now, the center is at the origin. So remember, we have a scale factor of 2 centered at the origin. So the center of this thing is at the origin. Let me get on a pen tool. There we go. All right. So what we want to do is we want to find a point on this line and just dilate that single point. And if we know if we can dilate that single point and we know the lines are parallel, then that takes care of the rest. Well, just like if we're dilating anything else on the coordinate plane, dilating from the origin is the easiest. The easiest point to work with is the y-intercept because it's just going to be directly above. So the y-intercept is 3 units above the center. We're dilating with a scale factor of 2, so just dilate this point. When you do that, the coordinates are 0, 3. We learned in the last lesson, you just multiply the coordinates by the scale factor whenever you're centered at the origin. So this is going to become 0, 6. And like I said, we know that they are parallel. So I already know the slope. Whoops, that last point was wrong. Here we go. So now there is my image. And I know its slope is 2, and now I know its y-intercept is 6, so I can write the equation of the image. It's going to be y equals 2x parallel, but this one has a y-intercept of 6. Okay, so that is the easiest. When you're centered at the origin, everything is just so much easier. But of course, you are not always going to be centered at the origin. Sometimes you're going to have to, let's change to red here just to be consistent. Sometimes you're not going to be centered at the origin. Okay, here's the thing. These require a lot of work. So you should do yourself a favor and you should perform the following test. You should test to see if the center is on the pre-image. Okay, you're going to see what I mean by that. What I want to know is the center of dilation on the pre-image line? Well, the way that I check that, I could graph it, I suppose. An algebraic way would be to plug in. So I've got my coordinates, x and y, and I have my equation. So let's plug in and see if that actually happens. Y is -5, x is 1, and we want to know if this is a true statement. Well, this is a true statement. So what that tells us is that the center of rotation is on the pre-image. I'm sorry, I said it again. Center of dilation. The center of dilation is on the pre-image. So if you're dilating from a center that's on the line itself, nothing changes because all those points are just kind of getting spread out, but there's an infinite number of them, so it makes no difference. So this is the best case scenario, is now you know that the image is actually the exact same line. Nothing changes. So do that quick test because I'm about to show you what happens when it's not on the line. It's a lot more work. And so do this simple test and save yourself from doing a lot of work unnecessarily. Let me show you exactly what I mean. Okay, so let's look at, we're gonna dilate this line. We're gonna have a scale factor 1/2 centered at -2, -4. Okay. The best thing to do here is just to graph this out. Okay. Oh, wait, we got to do our test. What am I saying? I totally forgot. Let's test to see if the center is on the pre-image. Okay, let's plug in. -4 equals -4 times -2 plus 8. -4 equals 8 plus 8 is 16. That's a no. Okay, so that means we're going to have to go through a bit of a process here. One thing that I know for sure, I know that the slope of the image is -4. I know that because it's parallel to the original. Let's go ahead and plot the original. I've got +8, 1, 2, 3, 4, 5, 6, 7, 8, and I have a slope of -4. So that's down 4 and right 1, down 4 and right 1, down 4 and right 1. Let me go ahead and draw in that line. Looks basically like that. Okay, so there's my pre-image line, and here's my center. My center is at -2, -4. There's my center. All right, so now all you have to do is pick any point on the pre-image and dilate that point from the center. Now you can choose any point you like. I would choose the one that's the easiest. What I find is that this one right here is easiest because notice that it's on the same, it has the same y coordinate as the pre-image, as the center, I mean. So this is just going to move directly to the right. Well, actually, it's a scale factor of 1/2. It's actually going to move this way. So this one is actually a little bit easier for me to do. It's not always going to be that easy, but you learned in the last lesson, how do I dilate a point when the center is not on the origin? You learned how to do that. So do that, and what that does is that gives us the coordinates of a point on the new line. So what do I mean by that? Okay, this is 1, 2, 3, 4, 5 away. So that means that if I split that in half, that's going to move to 2.5, which is right there. Okay, the coordinates of that point, I know that point is on my image now. The coordinates of that point are 0.5, comma, -4. Okay, so now I know the slope of the image because it's parallel to the red line, the original, and I know a point that's on that line. That's enough to get the equation. Okay, so here we go. We know that y equals mx plus b, and now we're just solving here. We're going to plug in everything we know. We know that y is -4. That comes from my point. We know that my slope is -4, and that my x value is 0.5. And I'm trying to find my b value. I don't know what my b value is. So this is, let's solve this. -4 equals -2 plus b. Add 2 to both sides. Looks like my b is -2. So what does that tell me? That tells me that my image is y equals -4x, parallel to the original, -2. Now let's go ahead and graph that, and you're going to see here's -2, here's down 4 over 1, down 4 over 1. Let's go ahead and draw in that line. And I want you to notice that it goes right through the point that we found in the beginning when we dilated. So that's how you deal when you have to dilate a line and the center is not at the origin. Okay, it's a little bit more work, which is why I say do this test, because if it turns out that that's on the line, then you don't have to do any of this. Okay, so do that simple test, and if you have to do the work, then you do the work. That's it.